We now begin Chapter 2 on graphs. Section 2.1 is on the distance and midpoint formulas. So let's review a few words or definitions from the Cartesian coordinate system for graphing. We'll make a little sketch here. I'm sure you're still familiar with all of these, but just to be sure. So recall the Cartesian coordinate system occurs with our two number lines that intersect. We have the x-axis, which is the horizontal number line, and we have the y-axis, which is the vertical number line, and they intersect at a 90-degree angle right here at what we call the origin, where x is 0 and y is 0. Remember, we use ordered pairs to determine where we are in the coordinate plane. The ordered pairs, it says ordered because x always comes before y. So there's our origin, here's our x-axis, our y-axis, and then we have four quadrants. This is quadrant number 1, quadrant number 2, quadrant number 3, and quadrant number 4. And what's distinguishable about each quadrant are the signs on x and y. So notice in the first quadrant, x is a positive. If this is 0, x is positive, and this is 0, y is positive. So we'd call that the positive quadrant, right? And then coming over here, now x is negative, but y is still positive. Put little parentheses around them. So this is where x is negative, but y is positive. Down here, they're both negative. And here, x is positive, but y is negative. So it's helpful to have that understanding about our Cartesian coordinate system. Let's explore the distance formula. Determine the distance between the points -3, -5, x, y, right, and 3, 3. First, we'll plot the points on the graph. So x is -3, 1, 2, 3, and y is -5, 1, 2, 3, 4, 5. So that's the address for this point, -3, -5. And 3, 3, starting back at the origin, 1, 2, 3, positive 3, 1, 2, 3, positive 3, and there's our other point. Connect the points with a line segment called D. The segment will be the hypotenuse of a right triangle that is created when the horizontal line is extended through -3, -5, and a vertical line through 3, 3. Well, let's see what they want us to do. I'm going to use my ruler to connect these two. Okay, and it says it's the hypotenuse of a right triangle. If I extend this line, I'm not making it as dark on purpose because I want our line segment D to stand out, okay? And this line. So now we have a right triangle. See, there's the right angle. This is the hypotenuse. The intersection of the two lines, the intersection of these two lines is this point, and what is that point? Well, x is 3, y is -5. So it's the point 3, -5. The length of the horizontal leg of the right triangle is, okay, here's our right triangle. Which is the horizontal leg? It would be this one. How long is that? Well, we can, because we're intersecting on integers, we can just count. 1, 2, 3, 4, 5, 6. It's 6. The length of the vertical leg of the right triangle is, again, count. 1, 2, 3, 4, 5, 6, 7, 8. It's 8. So the length of this hypotenuse, D, can be found using what? When you have a right triangle, what's a theorem that we use in right triangles to find lengths of sides? Do you remember? The Pythagorean Theorem? Okay, do you remember that? What does the Pythagorean Theorem say? Well, usually with our right triangle, we say we have an A and a B, and we call the hypotenuse C, and the Pythagorean Theorem says A squared plus B squared equals C squared. For this problem, we're calling this hypotenuse D. I don't know if you can see that, but we're using the lowercase letter D. That's for our C squared. So we're using A squared plus B squared equals, let's just go ahead and call it d squared because we're solving for d. So one side, and it doesn't matter which one you designate as a or b, right? So 6 squared plus 8 squared equals d squared. 36 plus 64, 100. Okay, so what do you think d is? Well, we'll take the square root of 100 and the square root of d squared, recalling that we're talking about distance, so we don't need a negative number here. We just need this, the principal square root of 100, and that is 10. So we found the length of d. But we could also do that using the distance formula, which comes from this. So I want you to notice that that length of 6 I could have found by finding the difference, this length of 6, the difference in the x coordinates. This was the point -3, -5. This was the point 3, -5. If I said -3 minus 3, I'd get -6, but of course it's a distance, so it would we just want the absolute value of that. So the difference between the two x's gave me that side, right? So if I take the difference between, if I have a point 1 and a point 2, right? So if I'm finding the distance between point 1, comma, and point 2, I want to subtract the two x's here. -3 minus 3, I get 6. And I'm going to square that because it said a squared, okay, plus b squared. Well, notice we got 8 because we counted, but if we had said these points, what was this one? This is 3, comma 3. If I take 3 minus -5, the difference of the y's, 3 minus -5 is 3 plus 5 is 8. So if I take my y2 and minus my y1, and then it says b squared, but I want the distance. What did we do last? We took the square root of all of that. So this is just a squared plus b squared, a squared plus b squared. This is just the same as taking the square root of both sides and saying that c is equal to the square root of a squared plus b squared, and we get a squared by taking the difference of the x's and b squared by taking the difference of the y's. So you need to know this formula, but it's not really so much memorizing if you know the Pythagorean theorem and understand how it's developed. Okay, so this just shows us where P1 is x1, y1, and P2 is x2, y2. Does it matter what order I put these in? If I put -3, what would we have? -3 and +3. -3 minus 3, I get -6. But when you square -6, you get 36. If I had done it the other way, 3 minus -3, 3 minus -3, I would have had +6, but I'm going to square and get 36. It doesn't matter. It doesn't matter what order you put your x's or your y's, you're going to square. Okay. Does it matter if I do the y's or the x's first? Could I have had 64 plus 36? Yes, I could. So it doesn't even matter which one of these you put first. Okay, so finally, let's note that distance is always positive, or it could be 0. So remember, that's what I was saying. When you take the difference, we're going to square it because we're not going to deal with a negative number in our result. This will always be positive. We'll always be taking the square root of a positive number, and we'll always be getting a positive number. If the distance is 0, which may seem weird, but the only way that can happen is then if P1 and P2 are the exact same point, then the distance between them is 0.